Good evening, everyone. My name is Alex Finlayson. The name is 24F1003 in the University of Soegijapranata Catholic University, and my faculty is electrical engineering. So today I'm doing the topic about chemistry, about an electrode, the conceptual about the electrode. First, let me open up the presentation. So we have two things that we need to know about a concept of the electrode. So the first thing, what is electrode? Well, basically, the electrode is defined as an electrical current. Two non-metallics such as electrolyte, semiconductor, or vacuum. The type of electrics, secondly, cathodes and anodes. Reactive, anode electrode, electrode in quantitative analysis. Thirdly, the standard hydrogen electrode. The standard hydrogen electrode has a reference potential of 0 volt and is used to calculate cell potential. The fourth, the principle of electrode. The multiple principle which consists of membrane across and intended ions can be transported. The fifth, the electrode can be made in a variety of material including platinum, lead, or gold and zinc. 6. Standard electrode potential. The standard electrode potential, a cathode and anode, can predict cell reactions spontaneously. 7. Marcus theory. Marcus theory explains how quickly the electron can move from one chemical to another. We're going to talk about the first one here. What is electrode? So basically, we have talked about this topic. An electrode is an electric conductor used to make contact with a non-metallic part called electrocircuit. Electrodes, where current enters from an anode and leaves through a cathode. Electrode basically transport the electron and process of electrolysis. So next we got the animation here in the next slide that I'm going to show you after I explain this. What is the electrode? So the electrocathode, the positive electrode where the reduction occurs, meaning the electron are gained. You can see the electrocathode is at the 3 there. That one position there is the cathode. And we got an electrode anode. The negative electrode where the oxidation occurs, meaning the electrons are lost. So the anode is on the left there, so on the fourth. So you can see the minus and the positive. The minus is actually an electron and the positive is a proton. So basically in the electrolyte water liquid. So basically the electrolyte is act like to make them split each other. The atom split into two, making them release the electron and the proton. Let's start. Let me show you the animation here. You can see the electron is moving and the proton is moving. So we're going to talk about the proton here. The proton move the membrane. The middle one of the electrolysis is the membrane. The electron can't go through the membrane except proton, because basically proton can go to a membrane and electron can. That's why we have an electrode. The electrode that is act like a transporting for the electron, basically transporting. And basically the electron move because there's the proton moving to the cathode, so it has like an electromagnetic field that pulling the electron. So yeah, we use that electrode to get some electron, so get electricity, electrical current. That's how we get electricity, gain electricity, to produce electricity, produce electron basically. So you can see here the voltaic cell reaction. The electron flow from anode to cathode due to the spontaneously redox reaction, and the electromotive force EMF, electromagnetic field, generate during the process. At the anode, species lose electron oxidation, while at cathode gain electron is reduction. Basically, an anode is oxidation, while the cathode is reduction. Secondly, we're going to talk about the type of electrode. There's two main types of electrode in the electrochemistry. There's active and inert. An active electrode participate in the electrochemical cell chemical reaction. Example of active electrode including zinc, copper, lead, and silver. Well, if from the inner electrode is quite the opposite because it does not participate in the electrochemical cell. The chemical reaction example of active electrode include the platinum, gold, graphite, and rhodium. So basically, the electrode are an electrical conductor that transport electron from one half cell to another. The two electrode is an electrolytic cell are connected to a different end of DC, a direct current, electric source. Anodes, the electrode connected to the negative terminal of the battery, it attract positive charge ion, while the cathodes are the electrode connected to the negative terminal of the battery, it attract the negatively charged ion. My mistake there. It shouldn't be. The cathode, the electrode connected to the positive terminal, not negative. The positive of the battery attract negative because the positive and negative usually have to attract each other. If the negative and negative wouldn't be attracted to each other, also it would go to the opposite direction. So I can see that my mistake there. So the standard hydrogen electrode. Thirdly, the standard hydrogen electrode is the reference electrode with a potential of 0 volt that used to calculate the potential of other electrode. The definition here that the standard hydrogen electrode is the platinum electrode in contact with an aqueous solution. The hydrogen gas at the interface between the platinum and solution is in equilibrium with the solution. The purpose here, the standard hydrogen electrode is used to as a reference to measure the potential of other electrode, the standard electrode potential of the half reaction. The potential of half reaction measured against the standard hydrogen electrode. The process how this works is the first initial discharge allows the electron to fill into the highest occupied energy level of the PT. As this is done, some PT the hydrogen ions form to H3O plus ions with the water molecule in solution. The hydrogen and hydronium ions get close to enough there to where hydrogen is attracted to electron in the metal and form the hydrogen atoms. So as you can see here in the half reaction of this reaction, the hydrogen ions in the solution gain electron to form a hydrogen gas, which is observed at the platinum electrodes. The half reaction at the standard electrode system here should be standard hydrogen. Yes, system it is then. The half reaction is 2H and 2 electron that will turn into hydrogen gas. Fourthly, the principle of electrode. The principle of the ion selective electrode is that a potential difference is created when ions are transported from high concentration through a selective membrane. This potential difference is measured and used to calculate the ion activity in the solution. The ionic activity, the property of electrolyte solution, can derive from the law used to derive the chemical potential of solution. That by and Huckel developed the following equation of the calculated mean ionic activity in coefficient. You can see the formula here. On to the next. Next one, we're going to talk about the electrode material. When choosing an electrode material, it's important to consider the conductivity and the corrosion, resistance, hardness, current load, or form and size. Graphite and carbon, these materials are effective for small current and potential but corrode quickly. Titanium, however, has high resistance against corrosion and exceptionally mechanical property. Very exceptional. For composite carbon, activate carbon (CNT) and graphene are used to make the composite structure for electrochemical. Metal oxide, this include the PbO2 electrode and ceramic. 6. standard electrode potential. In electrochemistry, standard electrode potential is measure of reducing power of any element or compound EUAPC to value of the standard EMF, electromotive force, of a cell which molecule hydrogen under standard pressure is oxidized to solvate proton at the left-hand electrode. The basis of electrochemical cell, a galvanic cell, is always a redox reaction which can be broken down into two half reactions: oxidation, loss of electron by substance; reduction, gain the electron by substance. Lastly, the Marcus theory. The Marcus theory is a framework that explains the rate of electron transfer. The reaction in electrode, it incorporates factors like activation, free energy, reorganization, energy, and apply external potential. The activation of process charge transfer. The barrier an ion must overcome to cross the interface between an electrode and an electrolyte. That's it, all my presentation for today and this evening. I thank you guys, sir, everyone, for participating this presentation. I will end this right now.